Hello students, in this video I'm going to do some challenging O-level questions. The questions are taken from 2023 paper 2. The questions are 4, 6, 7 and 8. Right, so let's look at question 4. In question 4, you are asked not to use a calculator in these questions. And then you are also asked to use the identity for tangent 2a and show that tangent 15 degrees is equals to 2 minus square root 3. Right, so let's look at what is tangent 2a. Yes, tangent 2a can be expressed as 2 tangent a over 1 minus tangent square a. So in the earlier videos, I advised the students to remember all the formulas by heart so that it will be at your fingertips. Even though the formulas can be found in the formula sheets, it will not be that efficient in the exam if you have to look for the formulas in the formula sheet. So it is really advisable to remember all the formulas by heart. Alright, so to find tangent 15 degrees equals to 2 minus square root 3, there are several wrong approaches by the student. One of them is you are actually substituting angle A to be 7.5. And because the question says do not use a calculator, so if you start off by finding tangent 15 degrees equals to 2 tangent 7.5 over 1 minus tangent squared 7.5, basically you just cannot proceed from there, because there's no way that you can actually evaluate tangent 7.5 without using a calculator, and even using a calculator it won't give you an exact value. A second approach is you actually let 2 tangent a over 1 minus tangent squared a equals to 2 minus square root 3. And in this case here, you end up, it's like you really have done a lot of work. It's like, oh, you could be on the right track, but actually you're not, because you're not doing any proving at all. You're just basically trying to solve the equations by finding the values for tangent A, which is actually trying to find the values for tangent 15. Right, so after doing all the hard work, you realize that, again, you can't continue. It's too difficult to continue, plus you're not actually doing any proving. Then what is the correct approach? So let's look at the next slide. Alright, so the key word here is when you see questions involving trigo that says do not use a calculator, the first thing that comes to your mind is these questions actually involve special angles, because it's only special angles that can actually, the trigo functions of a special angles that gives you an exact value. Right, and so what are the special angles that we are referring to here? Yes, in these questions here, right, recognize that if you take 15 degrees times 2, that will give you 30 degrees, and 30 degrees is a special angle. Right, and to remember special angle, usually there's too many things to remember, so I usually like to draw a right angle triangle using the trigo ratio to remember the values for this special angle. And there's some values that when you use a calculator that will give you an exact value. Like for example, sine 30 degrees is half. Right, so with that, you can actually draw your right angle triangle to find your adjacent side using Pythagoras theorem, and that is square root 3. And from there, we can see that tangent 30 it's 1 over square root 3. So we can substitute A to be 15 degrees, so that 2 tangent 15 over 1 minus tangent squared 15 is equals to tangent 30, which is 1 over square root 3. Tangent 30 is 1 over square root 3. And with that, we can just do a cross multiply. And we bring everything to the left-hand side. Right, here what I've done is I multiply by negative throughout. Every term multiply with a negative to make the coefficients of tangent squared 15 degrees to be positive. Right. And then the next thing is that if you look at what you're supposed to show, the answers is actually in terms of cert. And that gives you an idea that you have to use the quadratic formula. Right, so to use the quadratic formula, let's write down the values for A, B, and C. A is the coefficients of tangent squared 15, which is 1. B is 2 square root 3, and C is negative 1. So with that, we can substitute into your quadratic formula. Right, and that gives us two values. Okay, and why do we reject the negative one? Because tangent 15 degrees in the acute angle, and it is in the first quadrant. And trigonometric ratios of all the angles in the first quadrant will be positive. That's the reason why we reject the negative answer. Right, so for the second part, we are asked to prove that tangent 15 degrees minus tangent 105 degrees equals to 4. So tangent 15 degrees were found earlier on to be 2 minus square root 3. Now remember that even if you cannot do part A, it does not mean that you cannot use the answer for part A. You can still use the answer for part A, right, to help you to get the answer for part B. So in this case here, you don't actually throw away the whole questions. Alright, so for tangent 105, as what we have mentioned, this question says that we cannot use a calculator. So that gives you an idea that you have to use, it's a questions involving special angle. So what do you think 105 degrees can express of in terms of two special angle? Yes, you can write it as tangent bracket 60 plus 45. And we can use the addition formula to simplify, to rewrite tangent bracket 60 degrees plus 45. This is the one that I'm referring to, the addition formula. Right, when you use the addition formula, take notes of this. This is very important. You can see it's not the same. Right, if it's plus at the numerator, at the denominator is a negative. If it's negative at the numerator, denominator is a plus. Okay, as what I have demonstrated here. Right, again, tangent 60, if you refer to the diagram. Oh, okay, I have drawn the diagram here, so I need to erase this. Okay, if you look at these diagrams, right, so tangent 60 is square root 3. And tangent 45, we can use a calculator that gives you 1. Alright, so we cannot stop here because we need to rationalize it with the conjugate sets. Okay, so what I've done here is I take 4 divided by negative 2 to give you negative 2 here, and 2 divided by negative 2 will give you negative 1 square root 3, which is just negative square root 3. Okay, so with the values for tangent 15 and also the values for tangent 105, I can just plug it into this, and remember to bracket this one, very important, because you need to bracket it so there's a change of sign, so that the negative and the negative become positive. This one also become positive. Right, and the answer you get is 4 as what is requested in the questions to prove. Right, so let's look at question 6. Question 6a, we need to show that 2x plus 1 is a factor of the polynomial, cubic polynomial, and hence factorize the cubic polynomial completely. Alright, so to show that 2x plus 1 is a factor, we need to find the remainder. And if the remainder is 0, we can conclude by saying that using factor theorem, 2x plus 1 is a factor. So first thing first, that we let fx, we give the polynomial a name, we call it f of x. Right, and we substitute your x to be negative half. Where do I get that? It's you let 2x plus 1 equals to 0. So from there, 2x is equals to negative 1, x is equals to negative half. Alright, so do not just put f bracket negative half equals to 0. Alright, you need to show all this working. Okay, so need to show all this working, and then we conclude that and you do not just stay there. You need to do some explanation. And what are the explanations that are needed? We need to explain that since the remainder is equal to 0, using factor theorem, 2x plus 1 is a factor. Alright, so the next part is to factorize it. So there are two ways of doing it. You can use the long divisions, or you can use compared coefficients of similar terms on both sides. Alright, so to use a long division, okay, I have a video that actually show you how to do long division, so I won't go into details how to use the long divisions. Alright, and after we have done that, we can break it up into a linear factor. This is your linear factor, and this is your quotient. And your quotient is actually a quadratic polynomial where you can factorize further. Alright, so this is using long divisions. So otherwise, you can use compared coefficients of the similar terms. Alright, so basically, I need to find my quadratic polynomial here, quadratic factor. So I need to find the unknowns a, b, and c. So basically, I just need to multiply. Just take 2x times ax squared to get the first term, and then there's the x squared term and the x term. So it's up to you whether you want to compare the x squared term or the x term. And then of course the last term is just getting 1 times c to give the last term. I also have a video on that. So if you've forgotten how to do that, please refer to the earlier video. Alright, so this is what we're going to do. Okay, I put a dot here is because there's some x term there which I'm not interested to compare. I'm interested only to compare my x squared term, the first term, and then the last term. Right, so your 2x cubed is to be compared with your 6x cubed. That gives you a equals to 3, and then your ax squared plus 2bx squared will be compared with negative 7x squared. So that will gives you, after finding the values of a, you can put it inside here, and that will let you find b equals to negative 5, and then the last term will be just c equals to 2. Alright, so we put all these things together, and we get the same answer as what we have found earlier on using long division. Right, so you can either use the first method or the second method to factorize the polynomial, cubic polynomial completely. Alright, let's look at part B. Part B, we're asked to solve equations involving exponential equations. So for such exponential equations, we know that we need to use this thing called the substitution method. But before we can actually use the substitution method, we need to work on this guy, because if you see that all these are in terms of base 2, right? So for 4 to the power of y, we need to write it as 2 to the power of 2 times y. That gives you 2 to the power of 2y. I think I have an explanation for that. Wait, let's look at the explanation. Right. Okay, so this one, how does this happen? That is, we actually apply one of the rules we've learned in indices. Let me see whether I explained that. Oh, I didn't explain it. Okay, never mind, then I'll explain it here. If you were to recall, a to the power m bracket times n can be written as a to the power n bracket m. So therefore, 2 to the power of 2 bracket to the power of y, you can actually interchange the indices, alright, to write it as 2 to the power of y, then to the power of 2. Okay, and then we're going to substitute. Oh, then another thing is that this one here, you take note. This is a to the power negative n can be written as 1 over a to the power n. Wait, I think I have explanations on that. Okay, anyway, so we're going to substitute to the power y to be a. So this is what we get. Alright, so if you substitute to the power y to be a, that's how you get 6a squared plus 2 times 1 over a equals to 7a plus 1. And of course, this one is just 2 times 1 gives you 2, 1 times a gives you a. Okay, the next thing is I'm going to multiply by a throughout. That means I times a here, times a, times a, times a to get 6a cubed plus 2 equals to 7a squared plus a. Okay, and you'll see that it's actually the cubic polynomial that we asked to factorize in part A. So therefore, I can actually write down the linear factors. Oh, okay, that explained. I've already explained that. Never mind. Yeah, okay, fine. All right, so we can write down the linear factors for your 6a cubed minus 7a squared minus a plus 2, which you have already done it in part A. So therefore, your answers for A will be negative half, 2/3, or 1. But remember that a is a substituted value for 2 to the power y. So we need to find the values of y. So when a is equals to negative half, 2 to the power y is equals to negative half. And half is actually 2 to the power negative 1. So what is happening here is I have a positive on the left and a negative on the right. So such equations is not valid at all. So therefore, we need to reject that solution. And when a is equals to 2/3, 2 to the power y is equals to 2/3. So here I would have to bring common log to both sides. Common log is log base 10, is the one that can be found in the calculator. Okay, and I can use power law for this to bring down your y. So y log 2 equals to log the power law, if you were to recall, right? And so therefore y is just log 2/3 divided by log 2, and that gives you negative 0.58, negative 0.585. We're not done yet, because when a is equals to 1, we still have one more values for that. So 2 to the power y equals to 1, and of course you can write 1 as 2 to the power of 0. So therefore y is equals to 0. All right, let's look at part C. Part C, what the questions want you to do is show that the negative solutions is the one that we obtain for y to be negative 0.585. So what they're trying to say is that instead of presenting the answer for y as negative 0.985, they would want you to express it in the form 1 minus log b base a. That means they want you to find y equals to 1 minus log b base a. And then write down the values of a and b, where a and b are integers to be determined, means after expressing it in the form y minus log b base a, you need to write down what is a equals to and what is b equals to. So this is what the questions wants you to do. What else to do? Right, so for y equals to negative 0.585, you have to recall that is when we let 2 to the power of y equals to 2/3. Yes, so we will have to work from here. And since the answer has to be expressed something minus log, so it means that we will be using the laws, logarithmic laws that we have learned. So what are they? Right. So for for any log to be defined, of course, a must be more than 0, a cannot be 1. Okay, this is a very useful one to remember. Like log 10 base 10 is 1, log 2 base 2 is 1. This one is a product law, the power law, and of course your quotient law. Okay, right. So if you look at what you're supposed to get, can you see there's a 1 there? So basically you have to bring log to both sides. It's just that you need to choose what base to use. So to get 1 means I would have to bring log base 2 to both sides. Yes. So from here you see that I can apply the power law to bring my y down, so that I have log 2 base 2, and log 2 base 2 is 1. And here I actually applied the quotient law, right? And log 2 base 2 is 1. So here I will just get y only. And again also this is 1, right? And basically we are there already. It's just that we need to compare with 1 minus log b base a. And you see that the values for a is 2 and the values for b is 3. Okay, if you look at question 7, this one is a bit tricky. You'll see that it's very different from the usual kind of trigo graph questions we've done, right? Usually if you're asked to find the here you're supposed to find a, which is the amplitude, and b, which is the coefficients of x. You'll see that usually for such questions they'll give you maximum and minimum point, and then from there you can find your amplitude, right? Here is very different. Okay, you're just given 2 maximum point, and then that's it, and you're asked to find the values of a and b. So your concepts must be strong. What do I mean by concept must be strong? It's you will have to go back to your basic shapes if you were to recall. For y equals to cos x, right? You see that the period for y equals to cos x is 2 pi, right? And the 2 pi is actually, if you look at the cosine curve, one maximum point is 0, 1. The second maximum point is 2 pi, 1. And therefore the period is actually the range between 2 maximum point. The range between 2 maximum point will give you your period. So therefore, to find the period, it's just taking this, the x coordinate of your second maximum point minus away the x coordinate of your first maximum point, and that gives you pi, right? And then to find another way to finding the period is to take 2 pi divided by the coefficients of x here, which is your b. So that means 2 pi divided by b will gives you the pi, right? So just do a cross multiply and you can find b to be 2. Then to find the values of a, you can just either use this maximum point or the second maximum point, substitute into this equation, and you can find your values of a. So I'm using 7 pi over 2 comma 10, so I'm going to substitute my y to be 10 and my x to be I already found the values of b to be 2. I can just plug it in, and x will be 7 pi over 2. Okay, and if you use a calculator to evaluate this, only thing is make sure that, okay, this one will actually end up having cosine 7 pi, and you can either change the calculator mode to radian. If not, you can just continue with degree. Just use a calculator to key in cosine bracket 7 times 180 degrees, because basically pi is equals to 180 degrees, and that gives you -1. Okay, so from there you have 10 equals to a times -1, so a is -10, right? So this is it's not the usual way the usual kind of questions we have seen, you know. Yeah, so therefore, you need to have very strong concepts. All right, so if you look at these questions, again, you'll see that it's very unlike from the previous kind of questions you have done in other years. Right, for these questions, you're given a particular travel in a straight line, and it conforms to this equation where v is 5 sine 0.2t plus c. C is a positive constant. Basically, c is just the y-intercept value or the v-intercept value, because you're talking about v in versus t. So you're supposed to find the smallest value of c such that the particle will never change the direction. What it's trying to say is particle never change the direction means if the particle is traveling in a positive direction, it will always be positive, positive, positive. That means it just keep traveling in the straight line. It won't make a U-turn. You make a U-turn is when it changes the direction. So that's what they're trying to say. So that's what they're trying to say is it's when your v it's more than or equal to 0. But I'm going to use another way to explain to you. If you look at the curve for v equals to 5 sine 0.2t. This is how your curve will look like, right? The amplitude is 5. Right, so you will see that this curve here, it does change the direction at this part here, right? From here to here is positive, and then from here onwards it becomes negative. This is it changes directions. So what we want is such that the curve will not change the direction, means we want the curve to be entirely above t-axis. Right, that means I want to shift my curve upwards. Oops, this is v, sorry. I want to shift my curve upwards. Right, so of course my curve can go further up and up and up, but then the minimum value of c will be this value here, which is equals to 5. Basically, c is actually your v intercept value as when the t equals to 0. When you let t equals to 0, sine 0 will be 0, right? So c is just your v intercept value. So another way of looking at it is like this. Okay, the 5 sine 0.2t, the minimum is negative 5, maximum is 5. So when you plus c to both sides, this will happen. And since we want your velocity to be more than equal than 0, that means negative 5 plus c will be more than equal than 0. And from there, your c is more than equal than 5, so the smallest value of c is 5. Alright, let's look at part 2 of the questions. In this case here, you're given c equals to 8. Right, so c equals to 8. So that means the minimum value for c is 5, right? And it happens such that the no motions, the particle will not change the directions. Okay, and then because if it does not change the direction, means there's no turning point at all. So it kind of make life easier. Why do I say make life easier? Because you're supposed to find the total distance traveled by particularly the third second of the motion. So since there's no turning point, you can actually find the total distance traveled in the first 3 seconds, then minus the distance traveled in the second. What am I talking? That means to find the particle traveled in the third second is to find the distance traveled in the first 3 seconds, then minus away distance traveled in the first 2 seconds. Alright, let's write down the formula to find velocity first. Okay, and to find the distance means I need to integrate the velocity. Okay, integrate the velocity to find distance. So I'm going to integrate your velocity. When you find distance, like what I mentioned here, the two limits I'm going to take is 3 and 2. That means I find the distance traveled in the first 3 seconds minus away the distance traveled in the first 2 seconds. Okay, to find the distance in the third second only. Alright, so when you integrate sine, you get negative cosine. When you integrate sine 0.2t, you get negative cosine 0.2t, and you need to divide by the differentiation of 0.2t. So you differentiate 0.2t, you get 0.2. So that's explain my 0.2 here, and that explain my negative here. And when you integrate 8, you get 8t. Okay, and we are actually integrating from 2 to 3. Already explained earlier on. Okay, why is it 2 to 3? Okay, so I'm going to substitute t to be 3 first, and then minus away, substitute t to be 2. So do not skip any steps. I think it's important that you write down. Some students will just try to punch everything using the calculator, and then you'll see that you're actually prone to making mistake. So it's best to show this step and this step by substituting your t to be 3. So you get 0.2 times 3 give you 0.6. Divide by 0.2. 8 times 3 is 24. Minus the bracket. The negative must be there. Okay, 0.2 times 2, 0.4, so on and so forth. Then this step here, okay, you can just use your calculator, but be very careful. When you punch in the calculator, make sure the square bracket is there and the negative, everything is there. And then you would get the answer to be 10.4 units. Right, let's look at question 8. Question 8 is a very interesting question. You are given a wooden framework, and the wooden framework is actually made from 7 pieces of wood. 7 pieces, so this is 1, 2, 3, 4, 5, 6, 7. Okay, 7 pieces of wood joined together to form a wooden framework. And you asked to find the area enclosed by the framework, in terms of r and sine 2 theta. Okay, so since they're symmetrical, I just need to find the area of one triangle, then times 3. So to find the area of one triangle, I'll be using half AB sine C. And if you look at what you're supposed to find, it must be in terms of sine 2 theta. So that gives you an idea that it may not be wise to do it this way. Some of you may want to do it this way, right? And then you go on to find, I don't know, the height, and then find the base, right? Half base times height. Then you find that it's more complicated, because if you use this method, you will have cosine theta, sine theta, and then from there you need to convert it to sine 2 theta. So a better way would be recognizing that this is an isosceles triangle. So if this is theta, this angle will be 180 minus 2 theta. And I can use half AB sine C. That means I'll be using this angle, because this angle have a 2 theta there, you see, which is why it's required here. Okay, so let's do it now. Let's erase this one. Aiyo, so messy. Okay. Right. Okay, times 3, like what we mentioned, because there are 3 congruent triangle. This one here, it's your addition formula. If you were to recall, sine A minus B is sine A cos B minus cos A sine B. Alright, so we can just work it out. Yes, and you end up getting sine 2 theta, because sine 180 is 0. And sine cosine 180 is negative 1. So negative times negative 1 will gives you positive sine 2 theta. Okay, so that's how you do it. Okay, and then you're asked to find the maximum possible area enclosed by the framework and the value of theta at which it occurs. So this will actually require you on the understanding of your sine curve, the maximum value for sine and the minimum value for sine of any angle. So the maximum value for sine 2 theta is 1. So therefore the maximum area is 3 over 2 r squared. And when sine 2 theta is equals to 1, that means what is the angle that will give you okay, what is sine inverse 1 if you were to go back to your basic sine curve, right? Your maximum is 1. And that happens when your angle, this is y equals to sine theta, that happens when the angle is how much degree? Yes, 90 degrees. Okay? So sine inverse 1 is actually 90 degrees. So therefore your theta is 45 degrees. Okay, so part C of the question, you are told that this similar framework is made from a single piece of wood of length 8r sine theta. That means what they are trying to say is this plus this plus this plus this plus this plus this plus this will give you this. All right. So if you look at the diagram, okay, I already know the length of this, but what is missing is the length of BC, the length of AE, ED. I don't know those lengths. So I will need to find, right? Okay, and some of you may go and use this angle, use cosine rule and use this angle to find AE, but you will end up AE squared equals to square root equals to something AE squared. AE equals to square root something, which you find that is very complicated. It doesn't give you the answer that you want. The answer you want is in terms of 8r sine theta. That means it's not a double angle, it's just sine theta. So that gives an idea that we will not be using 180 minus 2 theta. So we will have to go back to our trigo ratio. You need to draw a right angle triangle to find the height. And don't need to find the height. Use a right angle triangle to find x. Okay? Using cosine theta. And x will be r cosine theta. So therefore AE is 2x. So it's 2r cosine theta. Alright, so I have AE, which is the same length as BC, same length of ED. So it's 2r cosine theta times 3. And then I have 4r. Okay, so I have 4r plus 6r cosine theta, and that value is equals to 8r sine theta. Okay, so I can divide by 2 throughout and also divide by r. That means I divide by 2r throughout. And I will get the answer as what the questions require me to find. Okay, so the last part of the questions require us to express 4 sine theta minus 3 cos theta in the form. This is the R formula, in the R formula format. And then after that, to solve it, because in part C, we have found 4 sine theta minus 3 cos theta equals to 2. So basically, we're asked to solve this equation. But to help us to solve this equation, we just express 4 sine theta minus 3 cos theta in the R formula, right, equals to 2, and then we're going to find the values of theta. Okay, so to do that, to express it in your R formula, okay, I hope you can remember. Let's write down the values of A and B. So A is 4, B is 3. And to find alpha is just tangent inverse b over a, which is tangent inverse 0.75, that gives you 36.87 degree. And to find r is basically square root of a squared plus b squared, which actually give you 5. So in other words, your 4 sine theta minus 3 cos theta can be written as 5 sine bracket theta minus 36.87. And that value is equals to 2. Okay? And from there, we have to find the values of theta. So basically, we need to solve this trigo equation. So we have to find your reference angle, which is your alpha. That is sine inverse 2/5. Okay, so theta minus 36.87 will be equals to 23.58. And theta will be equals to 60.4 degrees. Alright, so these are the few very challenging questions from paper 2 in 2023 A-Math O-Level questions. So it's worth going through all these questions again and trying them again on your own.